Hey guys, it's Miss Adams, and we're going to continue working through the Unit 12 test review. We are on page 2 now, so we're going to start with problem 4. And it has asked us to calculate the MAD for each data set. So the first thing it asked us to calculate is the mean, because we had to have the mean in order to calculate the MAD. So what I'm going to do is I'm going to go ahead and show you how you would do this by hand if you weren't using the data button in your calculator. So I'm going to have 2 plus 9 plus 3 plus 17 plus 14. And I'm going to divide that by the total number of points in this data set, which is 1, 2, 3, 4, 5. So I'm going to put that into my calculator just as it's written. 2 plus 9 plus 3 plus 17 plus 14. And then divide it by 5, which gives us a mean of 9. And in order to calculate the MAD, I've got to go ahead and use my clock method. Guys, if you prefer the table method, that's fine with me as well. Just make sure that you're getting the distances from your mean to each data point. So I've got 2, 9, 3, 17, and 14. Now, if I'm looking at the distances here, I want to make sure that they are positive. So the distance from 9 to 2 is 7. The distance from 9 to 9 is 0. The distance from 9 to 3 is 6. The distance from 17 to 9 is 8. And the distance from 14 to 9 is 5. I'm now going to add up all these distances and divide by 5. So 7 plus 0 plus 6 plus 8 plus 5 divided by 5. So that's going to give me 26 divided by 5, which gives us a MAD of 5.2. We're going to do the same thing with data set 2. We're going to add up the values, so 20 plus 15 plus 16 plus 19 plus 15, and that's 1, 2, 3, 4, 5 data points again. So 20 plus 15 plus 16 plus 19 plus 15 gives us 85. Divided by 5 gives us a mean of 17. So 17 is going to go in the middle of my clock, and I'm going to put 20, 15, 16, 19, and 15 around my clock, and I'm going to find these distances. So 17 to 15 is 2. 17 to 19 is also 2. 17 to 16 is 1. 17 to 15 is 2. And 17 to 20 is 3. So these are pretty close together. I'm going to add them up. So 2 plus 3 plus 2 plus 1 plus 2. And divide it by 5. So 2 plus 3 plus 2 plus 1 plus 2 is going to give us 10. Divided by 5 will give us a MAD of 2. Which means that our data is approximately 2 units away from each other. All right, guys, that's going to lead us to problem number 5. So I've given you a histogram of the national distribution of FICO scores, and we're trying to decide if what the shape, the outlier, and center of spread of this histogram is. So let's just look at the shape first. If I'm looking at this, it does kind of look like we have a lower tail. So I'm going to say that this is skewed left with a lower outlier because most of our data is concentrated to the right with a tail to the left. Since there is concentration to the left and we're skewed, we're going to use the median for our center because the median is not affected by those outliers. And then we'll use our IQR for the spread because, once again, the outlier is not going to affect your interquartile range. That's going to lead us to problem number 6. So we're going to be looking at some percentiles here given a box and whisker plot, but we need to go ahead and create these box and whisker plots from the data given to us. So it says the 5-number summaries below show the travel from Storybrooke to Quahog on a bus and a car. Construct a box and whisker plot for each the bus and car on the same number line. So guys, we're going to give similar number lines to each other. So guys, if you want to go ahead and ignore where it says on the same number line, we're not going to do that together just because it might get a little confusing. But we want them, when you're creating a box and whisker plot, you can't just put the numbers wherever you would like them to. It needs to be a consistent value. So this is something that I've noticed on the quizzes and on your any of your practice checks and thus forth, when you're creating a box and whisker plot for yourself, make sure that you are using a consistent number line. So for the bus, I'm just going to go ahead and go by values of 2. So I'm going to start off at 0, 2, 4, 6, 8, 10, 12, 14, 16, 18. And I put those a little bit too far apart from each other. I'm going to go ahead and start over. Sorry about that, guys. But 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So let's go ahead and construct that box and whisker plot. We have a minimum at 12. Q1 is at 15. Median is at 17. Q3 is at 22. And our maximum is at 32. So remember, we're talking about percentiles, and each of these quartiles is 25%. So between our minimum to Q1, that's going to be 25% of our data. Q1 to our medium is 25%. Median to Q3 is 25% of the data, and Q3 to the maximum is 25% of the data. We're going to do the same thing with the 5-number summary, or the box and whisker plot for the car. So I'll do 0, 2, 4, 6, 8, 10, 12, 14, 16, and 18. I made this one a little bit more spread out because we don't have as much as a spread here. We have a minimum at 8. Q1 is at 10. Median's at 11. Q3 is at 13. And our maximum is at 17. So once again, remember, each of these quartiles is worth 25%. And it's asking us on the box graph what percent of the data is in between 22 and 32. So I've got 22 to 32. This should be 25% of the data. On the car graph, it's asking what percent of the data is in between 10 and 17. Well, I've got 1, 2, 3 quartiles there, so that's 75% of the data. And then it says complete the socks for the car. So if I'm looking at the car, I need to go ahead and find my lower fence and my upper fence. So my lower fence is going to be my Q1, which is 10, minus 1.5 times my IQR. And my IQR in this case is going to equal 13 minus 10. So that's that Q3 minus Q1. So my IQR is 3. So my lower fence should be at 10 minus 1.5 times 3, which is going to give me 5.5. So I have a lower fence down here. And now I have an upper fence at 13 plus 1.5 times 3. So 13 plus 1.5 times 3, which is at 17.5. So by looking at this, all of our data lies within the upper and lower fences. So I have symmetrical data, no outliers, which means I can use my mean and my MAD for the center and the spread. All right, now we're on to problem 7. So I've given you a two-way frequency table for problem 7, and it says a large group of feral cats were rounded up downtown. The table shows some of their characteristics. So we're looking at long-haired versus short-haired cats, and then solid-colored versus multicolored cats. It says how many feral cats are solid-colored and short-haired. So this is a joint frequency. They need to be solid-colored and short-haired. And I'm just asking how many. I'm not asking for percent. So solid-colored, I know that there are 6 total there. But I want to look at solid-colored, or excuse me, 14 total there. But I want to look at solid-colored and short-haired. So there are only 10 of the total 31 cats that are solid and short-haired. Then it says how many multicolored feral cats are there. This is going to be a marginal frequency. So multicolored feral cats, there are 17 total. Then it says how many feral cats were rounded up downtown. So this is going to be our grand total, which is 31. Then it asks how many joint frequencies are in the table. So remember, joint frequencies means that there are two categories looked at together. And our first, so A was actually talking about a joint frequency, so there are 4 joint frequencies on this table. Then it says how many marginal frequencies are on this table. These are your subtotals, so there are 4 of the subtotals on this table, with 31 being your grand total. All right, guys, that completes page 2 of the Unit 12 review.